how to solve for x here. But the way that I learned how to do it, I'm not saying, the way I learned how to do it was if it's on top over here, it's on top over here. And so this becomes 5 over 0.48 is equal to x. Okay, now some people would break it down a little bit more. You take both sides divided by 5, and so you get 0.48 divided by 5 is equal to 1 over x, and you've got to get rid of the 1 over x, so you just flip them both over and end up with that, is what you would get. Okay, so that's how you would solve for x there. Okay, so if you see that again, which you will see it again probably on the quiz tomorrow over this, that's how you would solve it. So you might want to write that down if you want to. All right, 15 and 16 are dealing with ratios. It says in a certain, 15 says in a certain package of seed corn, there are 36 red seeds and 24 yellow seeds. In the second package, the red seeds was 51, the yellow seeds was 34. What's the ratio of red seeds to the yellow seeds in each package? So we're just going to say 36 over 24, and then 51 over 34. If you divide those out, what do you get? 1.5. Okay, don't leave it as a fraction. Okay, I'm going to divide it out because we'll use that ratio later on. So what that means is there's 1.5 red seeds for every yellow seed. Does that make sense? On B, what's the ratio of the red seeds to the total number of seeds? So this is 36 over 60, and this one's 51 over 85. What do you get for that? 0.6. Okay, and this one we could turn it into a percent and say that 60% of the seeds are red seeds, or we could say there's 0.6 red seeds per seed, which is a part divided by the whole. That's what a percent is. That's what they're showing you here in this ratio. Number 16. I'm trying to get 16 and 17 both up there. Maybe even get them straight. There. So 16, we're talking about ratios of boys to girls in a class. What's the ratio of boys to girls? If there's 10 boys and 15 girls, it's 10 over 15, which is 2/3. I'm just going to round to 0.67. There's 0.67 boys per girl. In other words, to put that into words. What's the ratio of boys to the total number of students? So that's 10 over 25, which what's that decimal? 0.4, and that could be a percent too. 40% of the students are boys. There's 0.4 boys per student. And then what would be the ratio of boys to girls if the class were 3 times larger, but the ratio of boys to the total number of students were the same? It's still going to be 0.4. Because you haven't, what you've done is you do what?
0.67 is boys to girls, not boys to total students.
It says boys to total number of students.
So what would be the ratio of boys to girls?
It's going to be, it says what would be the ratio of boys to girls if the total class were 3 times larger, but, oh, okay, you're right. So if this is the same, you're right, it's going to be 0.67. Okay? So there's 0.67 boys to girls, because all we're doing is we're making this 30 boys instead of 10 and 45 girls instead of 15. Right? So the whole idea here is what happens on C is exactly what happened in our lab. Doesn't matter how much you put in, okay, you always end up with the same ratio. Number 17, it says when various amounts of zinc react with hydrochloric acid, zinc chloride and hydrogen are produced. Which of the following ratios between the masses of various products and reacting substances are constant, regardless of the amount of zinc and acid mixed together? Well, the idea here is things that are added. Anytime we have something being added, it's not going to be constant, because just in our lab, the zinc wasn't all used up, right? Or if the zinc was all used up, the hydrochloric acid wasn't all used up. And so anything dealing with zinc added or hydrochloric acid added is not going to be constant. But anything dealing with zinc used up or hydrochloric acid used up or zinc produced or hydrogen, sorry, not zinc produced, zinc chloride produced, hydrogen produced, these are all going to be constant ratios. And we could have found any of these and we would have found they were constant. This is the one we did. This is 0.48. This is the reciprocal of the one that we did. And that's the inverse of 0.48, which is like 2.08 or something like that. That's going to be constant too. So the answer should be B, C, D, and E, and F. And a couple hundred years ago, before the idea of mass being conserved in chemical reactions was a thing, this is what scientists struggled with, is because they would put zinc in with hydrochloric acid and say I put this much zinc in and got this much product, and so the ratio wasn't constant. What they didn't realize is that just because they put the zinc in, it didn't all react, and it wasn't all part of the end ratio. Okay, once we got that figured out, then we could say that mass was conserved, and whatever you start with, you end with. Okay, and that's kind of how the law of conservation of mass came about. So what you need to do, there's two things. The first thing is on Canvas, there's a quiz for you over 6.2. So you can use your comp book on that. So get on Canvas, take the 6.2 quiz. Then we're going to do this, which was up at the beginning of the class. Some of you have this written in already. We're going to do the synthesis of water. What's the word synthesis mean again? To put together. So we're going to talk about how hydrogen and oxygen can be put together to make water.